Tutorial, we are going to talk about the derivation of mean and standard deviation of a negative binomial distribution. A negative binomial distribution is a model that allows you to count the total number of trials, including the successes that you want. So here, the expectations is the same as the mean, which can be gotten by the product of x times the probability function of the negative binomial distribution. So the probability distribution of x is going to be given by the summation. It's going to be given by x plus r minus 1 times probability of x times 1 minus p power r. So this is what we are going to substitute in our formula of expectation, and we are going to have, we're going to sum from x which is equal to 0 to infinity of x times probability function which is x plus r minus 1 p to power x 1 minus p to power r. So this is what we are having, and according to what we are seeing, this is written as a combination, so we are supposed to expand it in this way. So it's going to be, remember we are multiplying x times the probability function, so when we try to put 0 here, of course 0 times anything is a 0, so we are going to neglect that part, but I'm going to write it 0 times x plus r minus 1 r minus 1 probability of p by x 1 minus p to power r. Then if we do exclude the 0 because it is here, we can still write the same thing, but when the summation of x is starting from 1 to infinity of x times x plus r minus 1 r minus 1 p to power x, then 1 minus p to power r. So of course this part is going, and we are staying with this one alone, which is the summation of x to infinity x times x plus r minus 1 r minus 1 probability of x 1 minus p to power r. So as I told you that this is written as a combination, we are going to expand the combination part so that it helps us simplify up to when we get the formula that we need to get. So the summation of x, which is equal to, where x is starting from 1 to infinity of x, this one is a combination, so it becomes x plus r minus 1 factorial out of x plus r minus 1, then minus r plus 1 factorial and r minus 1 factorial, still times the probability of your failure to power x, and then this of success to power r. So this is what you have. When you simplify it, you're going to get that summation of x staying with your x plus r minus 1 up here over this, and that goes, and you stay with r minus 1 factorial and x factorial multiplied by that. So this is where we are. We do not need to have this x, so we need to get a way of expanding and cancelling it out. So the expansion part comes with dealing with this factorial, this and that. So it comes x is equal to 1 up to infinity, have your x here, you have x plus r minus 1 factorial out of x into x minus 1 factorial of r minus 1 factorial probability of x times this. So this and that do cancel out, and you stay with summation of x is equal to 1 up to x plus r minus 1 factorial out of x minus 1 factorial r minus 1 factorial root of x. So this is what we have. But from this equation we need to try and simplify further. So r1 minus r 1 out of r minus 1 factorial can be the same as r out of r into r minus 1 factorial, because of this. These two can cancel out and we still stay with our 1. But still this can be written as r factorial, so we have r factorial. Then we also have this. We have this, whereby we can introduce a useful 0 for it to become x minus 1 plus 1. And then it will become x. It will become p to power x minus 1 times p. Then we are also having this of 1 minus p to power r, whereby we still introduce the useful 0 and we have 1 minus p of r minus 1 plus 1, whereby we are going to have 1 minus p to power r plus 1 times 1 minus p to power negative 1. So what we have here is what we are going to substitute in this equation here. So my expectation of x is going to be the summation of x is equal to 1 up to infinity of r x plus r minus 1 factorial out of r factorial x minus 1 factorial probability of your failure to power 1, then the other one x to power 1 minus p into r plus 1 and 1 minus p to power negative 1. So you can see that now we have generated constants that need to be out of our summation, which is r, p and this one. So when we pull out our constants, which is r, p and 1 minus p to power negative 1, summation of x is equal to 1 up to infinity of x plus r minus 1 factorial out of x minus 1 factorial r factorial probability of x, and this is what you are having. So at this step we are going to introduce in some other variables. So we are going to let this power of p to be our w. So if it is our w, then x itself will be w plus 1. Okay, so this means that if w is equal to 0, then your x will be equal to 1. Then we are also letting your s to be r plus 1, of which your r will be s minus 1. So we are going to substitute what you have here, what we have lettered here to this in this part. So your expectation of x is going to be rp into 1 minus p for a negative 1 of the summation of x is equal to 1 up to infinity of x plus r minus 1 factorial x minus 1 p to power w 1 to power s. So even in this part where we have not yet substituted, we are also going to substitute r and rx, so that we have common variables of p of w and s. So it's going to be rp 1 minus p for negative 1 of this x Rx is W plus 1 plus RR, which is S minus 1, then minus 1. That is our factorial. Out of Rx, which is W plus 1 minus 1 factorial, RR, which is S minus 1 factorial. P to power W, then 1 minus P to power S. This is what you're having. So you try and simplify. You get RP 1 minus P to power negative 1 summation, which is equal to 1 up to infinity, of W plus S minus 1 factorial out of S minus 1 factorial W factorial probability of W 1 minus 2 power S. Therefore, we all know that this summation results into a probability mass function, so it makes it be a 1. So W plus S minus 1 factorial out of S minus 1 factorial W factorial to power W 1 minus P to power S is equal. Sorry, I forgot at the point of substitution I did not substitute for my x, but up here I said when x is equal to 1 then W should be equal to 0. So I'm replacing the x is equal to 1 with this. So I can repeat this step here and it becomes the expectation of x, which is equal to Rp 1 minus P to power negative 1 summation of W is equal to 0 up to infinity of W plus S minus 1 factorial S minus 1 factorial W factorial P to power. So, and this summation out of S minus 1 factorial W factorial P to power S is equal to 1. So when you substitute this whole summation as 1, we shall get our expectation or the mean, which is equal to Rp of 1 minus P to power negative 1 times the 1 that we have as the whole thing. Then we get our expectation as Rp 1 minus P to power negative 1. From this point, our expectation of x will become Rp out of 1 minus P. This is your formula for finding the mean of the negative binomial distribution. Now we are moving on to variance of the negative binomial distribution. So the variance of x is gotten from the expectation of x squared minus the expectation of x, that is the whole of it squared. What we want to derive is a standard deviation of a negative binomial distribution, but for us to do that we are supposed to have the variance and we get the square root of it, and then we get the standard deviation. So from here, the variance, we have the expectation of x squared minus the expectation of s, the whole of squared. We have this which can be substituted according to our previous answer, but we don't have this. So it requires us to first get this. So our first step is to get the expectation of x squared, which is going to be x squared, summation of x starting from 0 to infinity, times the probability function of our negative binomial distribution. So this is going to be summation of x is equal to 0, infinity of x squared, x plus r minus 1, r minus 1, probability of x. So this is it. Trying to split it, you will have 0 squared multiplied by the whole of this, the probability, which is this. So have x plus r minus 1, r minus 1, derivative of x, plus, when we are starting from 1, so the summation requires us to add from 1 to infinity of x squared, x plus r minus 1, r minus 1, derivative of x, 1 minus b to power r. So this one dies out and we stay with only this part, which is the summation of x equals to 1, infinity, x squared, x plus r minus 1, r minus 1 to power x, 1 minus b to power r. So we are going to expand what we are having. We know that this one is a combination, so our combination formula is going to help us expand. So this is becoming x squared times x plus r minus 1 factorial out of x plus r minus 1 minus r plus 1 factorial, r minus 1 factorial, b to power x, 1 minus b to power r. So this is what you're having, which simplifies to x squared x plus r minus 1 factorial out of x factorial, r minus 1 factorial, probability of x, 1 minus b to power r. So we are going to expand this. We have x starting from 1, infinity. The x squared is the same as x multiplied by x, then x plus r minus 1 factorial out of x, which is the x factorial becomes x into x minus 1 factorial, then r minus 1 factorial of b to power x, 1 minus b to power r. So one x dies out with the other, and we stay with summation of this starting from 1 to infinity of x, x plus r minus 1 factorial, x minus 1 factorial, r minus 1 factorial, probability of x. So this is what we are having. At this point, we are going to use our simplification methods to simplify the following. But 1 out of r minus 1 factorial becomes r out of r minus 1 factorial, which is the same as r out of r factorial. Then the probability of x, probability of p to power x will become p to power x minus 1 plus 1, which is probability of p to power x minus 1 times p. Then the 1 minus p to power r is becoming r minus 1 plus 1, which is times 1 minus p to power negative 1. So what you have here is what you're going to substitute there. Therefore, your expectation of x is becoming. So this is our point of substitution. The expectation of x squared is going to become summation from x is equal to 1 up to infinity of x, x plus r minus 1 factorial. Then the 1 out of r minus 1 becomes r out of r factorial. Then the x minus 1 is maintained times the probability times p to power x minus 1 and p to power 1, then times 1 minus p to power r plus 1 and also 1 minus p to power negative 1. So at this point we have generated some constants, which is r, this and that, which are going to be pulled out to have r p 1 minus p to power negative 1 over summation with x is equal to 1 up to infinity x into x plus r minus 1 factorial of r, x minus 1 factorial, r factorial. The r was already taken out. staying with p to power x minus 1 and 1 minus p to power r plus 1. So at this point, we are going to let. We are letting a w to be equal to x minus 1. So x will be w plus 1. Therefore, if x is equal to 1, then w will be equal to 0. Then we also let our s to be equal to r plus 1. So your r will be s minus 1. We are going to substitute this in our previous equation, which is now expectation of x squared becoming rp into 1 minus p to power negative 1 summation of now w, which is equal to 0 up to infinity. So where there is our x, we are going to put w plus 1. Then where there is our x, still w plus 1 plus r, which is s minus 1 minus r1 factorial out of x minus 1, whereby our x is w plus 1 minus 1 now factorial, r factorial, which is s minus 1 factorial, times p to power x minus 1, of which our x is w plus 1. Then 1 minus p r plus 1, which is that one. So you're having rp into 1 minus p to power negative 1 summation w is equal to 0 to infinity of w plus 1 of w plus s minus 1 factorial out of w factorial s minus 1 factorial. To power s. So we are going to split this thing. It's like opening bracket. The w goes with the whole of this and the 1 goes with the whole of this. So you stay with rp 1 minus p to power negative 1, that is into the summation of w is equal to 0 up to infinity. Now we are first taking the w part, w times w plus s minus 1 up to factorial out of w factorial s minus 1 factorial p to power w 1 minus p to power s plus the 1 times a summation of w plus s minus 1 out of w factorial s minus 1 factorial p to power w 1 minus p to power s. So according to what we are seeing here, this one is a probability mass function, which makes it equal to r1. But then this looks exactly, or it is the expectation of w, since we are multiplying w times the probability. So we shall now first bring out the expectation of w, which is this w plus s minus 1 factorial out of w factorial s minus 1 factorial to power w 1 minus b to power s. So from our previous formula that we proved, this one is also going to become sp out of 1 minus p. Remember, this is equal to 1 and this is what we have. So from here, the expectation of x squared is now going to be equal to rp into 1 minus p to power negative 1 into, so where we have this, we are going to put this, so SP out of 1 minus P plus R1. So now, but our S, we said our S is R plus 1. So RP 1 minus P to the negative 1 of R plus 1, R plus 1 times P out of 1 minus P plus 1. So here you're going to use your algebra to simplify at this point. Have Rp now out of 1 minus P into your R, P plus 1 minus P out of 1 minus P, which takes us to R, P out of 1 minus P squared, Rp plus 1 as your expectation of x squared. But remember, you are supposed to find the variance so that it takes you to the standard deviation. And your formula for variance is expectation of x squared minus expectation of x, the whole thing squared. So this is our expectation of x squared, so Rp out of 1 minus P squared of Rp plus 1 minus the Rp out of 1 minus P, this whole thing squared. So when you simplify this, you're going to end up with Rp out of 1 minus P squared as your variance. But then the standard deviation is the root of variance. So this is going to be Rp out of 1 minus P squared. And then we stay with root of Rp out of 1 minus P as our standard deviation.